Good morning, all. Honorable Institute of Technology, ASTE Prerana Gear Training Program, Subject Engineering Mathematics, Topics Calculus 2. Gamma function. So, gamma n equal to integral 0 to infinity e power minus x power n minus 1 dx, where n greater than 0. Gamma 1 equal to 1, gamma 1 by 2 as a root pi. Gamma n plus 1 is equal to n into gamma n, where n greater than 0. Gamma n plus 1 is equal to n factorial for all n belongs to z plus. In the last class, we have used gamma function. So the gamma n reverse L like simple. Gamma n equal to integral 0 to infinity e power minus x power n minus 1 dx, including limit. Then only you can apply the gamma function. So integral 0 to infinity e power minus x power n minus 1 dx. Instead of x, any variable can be replaced. Some of the gamma functions values, gamma 1 as a 1, gamma 1 by 2 as a root pi. Okay, root pi. Gamma n plus 1 can be denoted as a n into gamma n. Okay, n into gamma n, where n greater than 0. Any number, decimal number, fraction number, mostly fraction number in the integration you will get. Next, fourth one, gamma n plus 1 equal to n factorial. If n is the integer number, that is positive integer. Okay, 0 factorial, 1 factorial, 2 factorial, like that. 0 factorial value 1, 1 factorial also 1. You won't get negative factorial as well as the fraction factorial or decimal factorial. That's why the gamma function arises. So that is gamma n plus 1 equal to n factorial. Otherwise, if we get gamma n, that is n minus 1 factorial, if n is a integer. Another one, that is integral 0 to infinity e power minus ax x power n minus 1 dx. That's equal to gamma n a power n. That is a formula. So one reference problem. Integral 0 to 1 x log x power 4 dx. Here we are going to use a gamma function. So take the minus t equal to log x. Log x equal to minus t. Okay, the reason, if you get e power minus t, then only you can apply. That's why they take it up log x as a minus t. I mean, in place of variable function log x, replace as a minus t. That is otherwise, so you can mention as a x equal to e power minus t. So exponential and logarithms, opposite function. Apply here both side exponential for the assumption. First assumption, let it log x equal to minus t. Here apply exponential both sides. So e power log x equal to e power minus t. E power log x equal to x. Keep it in your mind. E power log x equal to x. That's why they have mentioned it as a x equal to e power minus t. Now differentiate, you will get dx, that is differentiation of e power minus t as a e power minus t into dt, like you can do. So apply the substitution in the given integration, that is limit will convert as a 0 to infinity. Okay, 0 to infinity limited. Okay, so instead of 0 to 1, it will be infinity. Okay, it is minus t, so it will be t equal to 1 by log x will get. That means 1 by log 1 upper limit. For upper limit, when you identify t equal to 0, sorry, x equal to 0, log t equal to 0. When x equal to 1, what is the t value? So that is t equal to 1 by log x will get. That means 1 by log 1. So log 1 value 0, 1 by 0 infinity. That's why in the integration they have put limit. It is not minus infinity, that is 0. So 0 to infinity only will get. Inside we have to replace the function instead of x in the form of t. So that is log x as a minus t. Okay, so that is x log x we are getting. So that is e power minus t into minus t power 4 and minus e power minus t dt. like that we are getting. Okay, so that is instead of log x, what you have to do? So that is minus t. So that is minus t power 4. That e power minus t also whole power 4 will get. So that is e power minus 4t. It will be e power minus 4t. T power 4 will get. Then for dx, you will get minus e power minus t dt. Minus e power minus t dt. We know that e power minus t whole power 4 is not e power minus t whole power 4. Okay, it will be e power minus 4t. Carefully, you have to apply the power for the exponential function. So now exponential e power minus 4t into e power minus t will convert as e power minus 5t. Then minus and minus getting cancelled, you will get the value that is 0 to infinity e power minus 5t t power 4 will get. That t power 4 we can write as the gamma function form, that is 5 minus 1 dt, like that we can write. So that is using the above gamma function form. It is gamma n 5 power 5. Okay, so that is a power n, like that when you apply it, that is a equal to 5, n is equal to 5. That's why we are getting as a 5 power 5. That is fourth subdivision formula. That will 0 to infinity e power minus ax x power n minus 1 dx form. Compare with that gamma n equal to 5, a equal to 5. That's why we are getting gamma 5 divided by 5 power 5, that's equal to 4 factorial divided by 5 power 5. Further you can simplify. So that is gamma 5 as a 4 factorial. That is third subdivision concept. So this is the integration. Okay, so the last class we have go through the double integration. So here evaluation of the double integration. How do you identify the limits? You may get a problem in the multiple integrals case area, okay, and volume, like problems you may get by using multiple integration. We can solve such a problems. Okay, so in that, how do you evaluate in the multiple integration? Area integration, that is double integration. In that, one limit as a function limit, one limit as a constant limit. That's we have mentioned. So here, three possible cases. The third case is all the limits are constant limits. Okay, so that is when you look at it in the third case, all are constant straight lines. So x equal to c1, x equal to c2, y equal to d1, y equal to d2. Okay, all are constant straight lines. We may get different form of straight lines, but here constant straight lines. If we get like that, directly we put the constants as limits. Okay, for that no need to find any calculation to identify the limits. Okay, so we may get some other different straight lines, something like x equal to y, x equal to 4y. Different straight lines also there. That will not come under the case 3. So it will be under the case 1 or 2. Okay, so here in the fourth case, all the straight lines are constant straight lines. In that case, all the constants we have to make it as a limits of the function. Okay, so that's what they have mentioned. So double integral over R f of x comma y dx dy. So simply take it up the integration and apply the limit. So integral c1 to c2 for x limited, integral d1 to d2 for y limited, f of xy dy dx. So whichever is the inner one, that is going to be the first integration. Inner integration, get the first preparation. That is apply that integration with respect to that variable. Okay, so you can change for that constant. That means the first integration with respect to x, then y, or y then x. Both the case you will get same solution. So we have a change order of integration for the functional limit. Just like that, you cannot change. That is based on the integration. We have to identify properly and change the limit. So now come to the case one. In that, they take it up y limit as a functional limit. So see the diagram. So any diagram, any some unshaped region, in that you have to take one variable limit as a constant limit, one limit as a functional limit you have to take. So x-axis, y-axis, in that they take it up y limit as a functional limit. Based on the strip, that infinite strip, they have, I mean, strip, finite region, area. In that strip parallel to y-axis, so hence they take it up in the first case, y limit as a functional limit. So in that lower curve, upper curve, from that you have to identify the limit for y. So in that x limit as a constant limit. In that you can see the diagram x equal to c1 and x equal to c2. But in the problem as it is, you may not get, okay, just like the constant straight lines you will not get. Based on the bounded region, in that bounded region, to identify the constant x limit, if you are going to apply the case 1. So at which point it takes the least x value. So in that, with respect to x-axis, let's say the limit or least x value in that bounded region, you have to identify some least value you may get in that bounded region. So that the point you have to take, draw it as a imaginary straight line. So that is going to be the least x limit. So in this problem, in this case, we are getting x equal to c1 as a least x limit. So in the with respect to x, right side limit or bigger x value is considered like upper x limit, like we will get. So in that, otherwise bigger x value, bigger x coordinate value, we can take it up. So if you take it up as this problem, x equal to c2, like you'll get. So to identify the y limit as a functional limit, in the functional limit they draw the strip in the lower arc equation. So you may get some different arc equation or curve equation. That the curve equation, rearrange it y equal to what, like that you have to rearrange it. So that is y equal to some function of x, like we will get it. Okay, in that way you have to rearrange it. Okay, so that is y equal to pi 1 of x as a lower y limit. Next, upper curve or upper part of some line or whatever it may be, in that you have to rearrange that equation y equal to some function of x. That is, they have mentioned it as a phi of x. So integral c1 to c2, integral pi 1 of x to pi of x, f of xy, dy dx, dy dx. So in the limit function of x is there, that is y limit. So always inner limit as a function limit, outer limit, otherwise second integration as a constant limit, like only you can integrate. So if it is going for in the limits of the integration, in that what is that? X limit as a function limit, y limit as a constant limit, we are getting. Okay. So in the case 2, x limit as a function limit, y limit as a constant limit. So in that, with respect to y-axis, at which point or constant straight line, y takes the minimum value or least value. So in that lower part, you have to check in the based on bounded diagram. So there is y equal to d1. In that diagram, we are getting, okay. So then with respect to y-axis upper limit, y equal to d2 or maximum value of the y in the bounded region. So here left arc, that is the least x limit, that equation you have to rearrange it in the form of y. So x equal to pi 1 of y, like you can check. Otherwise some function of y, like you have to rearrange. So that is lower x limit or least x limit, x equal to pi 1 of y. Right side limit, horizontal strip here, where it's touched the curve, that strip equation, sorry, the curve equation, that equation you have to rearrange the x equal to what? That is x equal to some function of y you will get, that is upper y limit, like you will get. So in this manner, you have to identify the x and y limit. Okay, two ways you can solve. Most of the case, I mean, third one mostly won't get. Okay, that is a simple case. So now move on to the problem. Double integral over R. R means region or surface. Y dx dy. So this kind of problems, so you will get only simple function, not complicated one. So identifying the limit is the problem. So where R is the region bounded by the curves equations, That is y equal to x square, x plus y equal to 2. So x plus y equal to 2 is a straight line. Y equal to x square is a curve equation. That means parabolic curve. So that is in the form of x square equal to 4ay. Top open parabola, we take it up. So the top open parabola in the diagram, you can see that is going to be the top open parabola. So x plus y equal to 2. Straight line, but it is not a constant straight line. That we can call it as a intercept form of the straight line. So this x by 2 plus y by 2 equal to 1. We know that x by a plus y by a, x by a plus y by b equal to 1. That is ax. That is intercepting x-axis at a, y-axis at b. So in that way, we can think that given equation, straight line equation, we rearrange it as a x by 2 plus y by 2 equal to 1. So the straight line intersect at the x-axis 2.0, intersect y-axis at 0, 2. So join those 2 points, you will get the region, shaded region given in your problems. So in the first quadrant, they take it up in that we are going to integrate. From that, we have to identify the limit. So here strip is parallel to y-axis. That means y limit is function limited, x limit as a constant limit they are taking. So in that leftmost limit where it takes the least value. So in the bounded region, at which point it takes the least value, that anyhow that is already there as a x equal to 0. That means on the y-axis, x value is 0. So x equal to 0 is the lower x limit. So that is x equal to 0. And intersecting point we have to identify. Then only you can identify the upper limit at the coordinates intersection of the parabolic curve and the straight line. So that is understood. It will be 1, 1 because 0 to 2, 0 the straight line, and the function is y equal to x square. That is by substitution we can get the intersecting points. So that is x plus x square equal to 2. How come x plus x square equal to 2? That means substitute y equal to x square in the straight line equation. That's why we are getting x plus x square equal to 2. So that is make it as a equation, quadratic equation, x square plus x minus 2 equal to 0. That is factorize it, you will get x minus 1 into x minus 2 equal to 0. So x equal to 1 and x equal to minus 2. So x equal to minus 2 is out of our scope. That means that minus 2 point is in the second quadrant. That is not considered for the integration. So we omit it. So we take it up only the first quadrant, positive quadrant of x and y. So we consider only the x equal to 1. So substitute x equal to 1 in the parabolic equation. That is y equal to 1. Y equal to 1 you'll get. So the intersecting point is 1, 1 you will get it. So in the first quadrant. So based on the what is the shaded region, at the point 1, 1 it takes, I mean x takes the maximum value. X takes the maximum value. Further no shaded region, that is going to be the maximum point or maximum value x takes. So hence x equal to 0 to x equal to 1. So you can draw that imaginary straight line passing through the point 1, 1. So x limit fixed, that is x equal to 0 to x equal to 1. Now come to the y limit. Y limit based on the infinite strip, lower one, lower part, when you look at it, it touches the parabolic curve. So that parabolic curve, we have to rearrange y in the form. So that is already there in the form. So that is y equal to x square is the lower y limit. Upper y limit that strip is touches the straight line. That straight line is x plus y equal to 2. We have to rearrange as a y equal to what? That means y equal to 2 minus x. So that way we identify the limit for x and y. So y equal to x square 2, y equal to 2 minus x equal to 0 to 1. So double integral over r y dx dy, the limit, outside limit compulsory constant limit 0 to 1, and the inside limit as a x square to 2 minus x. Okay, so it's not decided by the function value. Okay, so it's decided by the curve equation value where it is there. Just like that, compare with the 2 minus x, x square is look like a big value. It's not like that. It's based on the diagram we have to identify. So the function is y dy dx. So inner integration with respect to y, y integrate with respect to y, that is y square by 2, and apply the limit x square minus 2x. Apply the limit 2 minus x whole square and y by minus x square. The calculation is not given, so that we can identify ordinary substitution method only. So 2 minus x whole square, 2 minus x whole square by 2 minus x square whole square. That means x power 4 by 2 will get simplify and apply again integrate with respect to x and apply the limit 0 to 1. Upper limit 1, lower limit not necessary. All the values become 0. So upper limit x by 1 and simplify, you will get 16 by 15 as a value. So in this kind of problem, identifying the limit is the important one. So one limit, constant limit, one limit, function limit. So in this, better take it up y limit as a function limit. If you take it up ulta, you will not get single double integration. Okay, it will be end up with the two double integration. So better we have to take it up y limit as a function limit, x limit as a constant limit. Okay, this way you have to take. Otherwise, it's I mean, if you put what is that, strip parallel to x-axis, identifying the limit, it's end up with two double integration. So hence, don't think like that. Those things we have discussed in the clauses. So okay, with the options, this one is a good question. So the value of double integral x y dx dy, where r is the region in the positive quadrant at the ellipse, x square by a square plus y square by b square equal to 1 is. Four options are given: a square by b square equal to 8, b equal to ab by 8, c equal to a cube b cube by 8, and d as a square b square by 4. So double integration over the first quadrant of the ellipse equation, x square by a square plus y square by b square equal to 1. So no finite constant of a and b. Sometimes we may get a and b by some constant. Okay, from the ellipse first quadrant diagram, we have to identify the limit and integrate over the region, that region. Okay, so that is it is mentioned. So for this case, you can integrate both the ways. That means you can draw the strip parallel to x-axis or y-axis. Both the case you can do. Both the case you will get same solution, same kind of solution. Okay, so here they take it up x limit as a function limit, y limit as a constant limit. So as per the concept of the ellipse, it is understood that is the ellipse intersect in the x-axis a comma 0, y-axis as a 0 comma b. Okay, so upper in the positive quadrant, upper point is 0 comma b. I mean in this. Okay, so we have to concentrate only on the first quadrant. So consider only the 1/4 of the ellipse. So in that, what is that? Y limit as a constant limit. So that means in that lower y limit is nothing but origin y equal to 0. That means x-axis, at the x-axis y value will be 0. So that is, you will get this one. X-axis is the lower y limit. Upper y limit is passing through the point 0 comma b. That is y equal to b. Y equal to 0 to y equal to b. Now x limit, that is leftmost is the lower x limit. So the leftmost term in the first on the bounded region, first quadrant, that is y-axis. That means x equal to 0. Straight line, constant straight line. This y-axis for the bounded region, leftmost one, this x equal to 0. Rightmost one is covered by the curve. So that the curve is what? X square by a square plus y square by b square equal to 1. So what we need to identify from that x value. So that is x square by a square. Take the remaining value to right hand side. you'll get x square by a square equal to 1 minus y square by b square. Next, the denominator a square cross multiply, you'll get a root of b square minus y square. So that's actually they take them inside LCM and they take the b outside. From the root, when you take it b outside, it's become a sub b. That's why they have put the limit like this. So you'll get x equal to x square equal to a by b root of b square minus y square, like you'll get it. That is plus or minus you'll get. So first quadrant, both x and y both will take positive value. X and y both will take positive value. That's why they take the x equal to a by b root of b square minus y square. Got it? First step from the ellipse, x square by a square is equal to 1 minus y square by b square. Next step, x square equal to a square into root of b square minus y square by b square whole divided by b square. Everything inside the root. The denominator take outside from the root, so that will convert as ba. So here x equal to plus or minus you will get. So that is a by b root of b square minus y square. That is for x. So first quadrant take positive value only. So now substitute these values in the integration and apply the integration. So that is integral 0 to b, constant limit, always outside limit. Inside limit, x equal to 0 to a by b root of b square minus y square, xy dy dx. So in the limit, that is x limit. So we have to integrate with respect to x. Here y as a constant because the function is xy. So keep as y as it is, x integrate, that is x square by 2, apply the limit 0 to a by b root of b square minus y square. So that is applied, you will get a square by b square into b square minus y power 2 whole divided by 2 into dy, like we'll get. So now whole divided by 2 and other constants you can take it outside, and my y multiply inside, I mean yes, so now you will get a square by 2 y square by 2 minus a square whole divided by 2b square into y power 4 by 4. So apply the limit, upper limit y by b, and take LCM and simplify. We end up with a square b square by 8. LCM was 8, 4 and 8 we have. The denominator 2 they have applied. In this step, denominator 2 applied the reciprocal. It will be a square by 2b square. That value multiplied inside along with outside y also. That's why we are getting this calculation. So now next problem, double integral over r xy dx dy, where r is the region bounded by x-axis, x equal to 2a. That is x square equal to 4ay. Consider the vertical strip. That is y equal to 0 to y equal to x square by 4a and x equal to 0 to x equal to 2a. So that is parabolic curve and x equal to 2a line. That is the bounded region, first quadrant, where it is shaded, that region only consider, not all things. X-axis, y-axis, then parabolic curve and the straight line x equal to 2a. So you will get the shaded region as a region will get. So in that y limit as a function limit. So lower y limit is x-axis, that is y equal to 0. Upper y limit is parabolic curve. That parabolic curve is x square equal to 4ay. We have to rearrange it as a y equal to what? This y equal to x square by 4a, like you can do. So now x limit in that x equal to 0 is the lower x limit because the curve, parabolic curve passing through the origin. From that only the bounded region started. Then rightmost or upper x limit is that constant straight line. So we can see it in the diagram. That is x equal to 2a constant straight line. So hence for x limit is x equal to 0 to 2a. So put this limit in the double integration. So outside limit, constant limit x equal to 0 to 2a, integral y equal to 0 to x square by 4a xy dx dy will get. So inner integration is with respect to y. So integrate with respect to y, that is y square by 2, limit 0 to x square by 4a, y by x square by 4a. So that means x power 4 divided by 16a square into 2. So that is 32a square will get, and outside x when you multiply it's become as x equal to 0 to 2a x power 5 32a square dx. That 32a square keep it outside as a constant, x power 5 integrate as a x power 6 by 6 and apply the limit 0 to 2a. So you will get as 64a for 6 divided by 6 outside constant into 1 divided by 32a square. Simplify, you end up with as a power 4 by 3. Okay, numerator a power 6, denominator a power 2. Simplify, you will get a power 4. So constants simplify, finally you will get in the denominator as a 3. So simple problem, integral 0 to 2, 0 to x e power x plus y dy dx. So direct integration. So this e power x plus y you can write as a e power x into e power y. So that is inside integration we have x in the limit. So that is y limit. Okay, in the limit x is there, that is y limit. If it is y is there, that is x limit. Okay, in the limit x is there. Inner integration is 0 to x. So that is y limit. So that is they break the function e power x plus y as a e power x into e power y. E power y integrate as a e power y. Limit is 0 to x. So apply the limit, upper limit y by x, that is e power x. Lower limit by 0, e power 0 will get e power 0 value 1. So that is after applying the limit, you will get as a e power x minus 1. Now multiply, that is e power x into e power x, that is e power 2x. Okay, e power x add the power. So x plus x as a 2x. Then e power x into minus 1, you will get minus e power x dx. So that is directly integrate, nothing is complicated. So e power 2x by 2 minus e power x and apply limit 0 to 2. So x by 2, you will get e power 2 minus 1 whole square divided by 2. Sorry, that is 2 wrong. Yes, e power 2 minus 1 whole square by 2 only. That is applying upper limit minus lower limit. Then simplify, you will get e power 2 minus 1 whole square. Okay, that is e power 4x by 2 minus e power 2 upper limit minus e power 0 by 2 minus e power 0. E power 0 is 1. 1 minus 2 minus 1. So that is minus 1 by 2. Apply all, you will get e power 2 minus 1 whole square divided by 2. It's like a minus b whole square. A equal to e power 2, b equal to 1. Like expand it, surely you will get this value. E power 2 square is e power 4. Consider the shaded triangular region shown in the figure. what is the double integral over xy dx dy? So that means from the region we have to identify the limit and integrate it. So that straight line, that intercept form of the straight line is x plus 2y equal to 2. That is cross multiply, we can make it as a x plus 2y whole divided by 2. So that is x by 2 plus 2y by 2. So it is converted as a x by 2 plus y by 1 equal to 1. So that is at x-axis, its intercept point 2 comma 0, and the y-axis as a 1 comma 0. From that, we can identify intersecting points, then identifying the limit. So x limit constant limit, y limit is a function limit as per the diagram. So x equal to 0, x equal to 2. Rightmost point in the shaded region, bounded region. At that point, it takes the x value, that is the maximum x value, that is 2 comma 0. So that's why they take it up the limit as a x equal to 0 to 2 for x. Y limit, that is lower y limit is y equal to 0, x-axis. Upper y limit is x plus 2y equal to 2, that straight line. From that, we have to identify the y limit. So that is rearrange it. We will get as a 2 minus x whole divided by 2 as a y limit. X plus 2y equal to 2, rearrange it, y equal to what? So that is 2y, keep it this side, and take x to other side, you will get 2y equal to 2 minus x. Then the coefficient of y cross multiply. So that is 2 minus x, 4 divided by 2 we get. So that's it, we got the limits of the integration. So that is inner limit, get the functional limit. So that is 0 to 2 minus x by 2. Outer limit 0 to 2. Function is x y dy dx. dy dx. So inner integration with respect to y. So there is y square by 2. That x as a constant. So apply the limit 0 to x square by 2 minus x by 2. And apply it upper limit, lower limit y by 0, no value. That is 2 minus x whole square by 2. Expand it and multiply, then whatever value we are getting, that one integrate there in the form of constant, and the x surely will get. Then integrate with respect to x and apply the limit 0 to 2. Lower limit for this case 0. Okay, x by 0. Here no exponential to get finite value. So here simply x by 0, it's become as a 0. Okay, so then simplify, integrate, and apply the limit, you will get as a 1 by 6. Next, parabolic curve and straight line. So that is the area enclosed by the parabola y equal to x square, and the straight line y equal to x. Area, that is integral 0 to 1 x minus x square into dx. So x square by 2 minus x cube by 3, integral 0 to 1. That is 1 by 2 minus 1 by 3. That's equal to 3 minus 2 by 6. That is 1 by 6. It's actually using Green's theorem concept. Integral x limit x dy plus y dx, x dy plus y dx, integral over c, like we'll get of 1 by 2 integral over c u dx plus v dy, sorry, x dy plus y dx, like we will get. That's why we are getting this function by substitution y equal to x square, we are getting as x square. So go through that. Next problem. using parabolic arc y equal to root x, 1 less than or equal to x less than or equal
ஹலோ
to.
சார்.
Yes, sir.
ஹலோ
Yes.
சார், இந்த ஃபர்ஸ்ட் கொஸ்டின் திரும்ப ஒரு தடவை நடத்துங்க சார். இந்த முன்னாடி இந்த ட்ரையாங்கிள் இருக்குல்ல, ஷேடட் ட்ரையாங்கிள் ரீஜன்,
Yes.
அதை மட்டும் மிஸ் பண்ணிட்டேன். ஒரு தடவை திரும்ப நடத்துங்க சார்.
Okay. So the triangular region x plus 2y equal to 2. That straight line x plus 2y equal to 2. That one intercept form we can write x by a plus 2y by 2 equal to 2. Okay, so that is x by 2 plus y by 1 equal to 1 in the form of intersect. So that is intersection form, intercept form. The x by a plus y by b equal to 1. That form, first quadrant intersecting at the point a comma 0 and 0 comma b, like this. This point a comma 0, this one is 0 comma b. So based on that, here 2 comma 0, this one is 0 comma 1. X value 0, y value 1. Like that you'll get the triangle shape region will get. Function is xy, and from the triangular region we have to identify the limit. That is one limit function limit, one limit constant limit. Based on the diagram, here x limit as a constant limit because strict parallel to y axis. So that is x limit in that it's a passing through the origin. Here it takes the least value. So that is x equal to 0. Constant constant y axis, that is x equal to 0. That is the lower x limit. Here at which point it takes a maximum value for x. So here it takes a maximum x value. So that is the maximum point of x. So draw the imaginary straight line like this. Follow the cursor like this you will get. So that is x equal to 0, that is y axis, x equal to 2 in between the bounded region exists. Constant limit we have fixed. Next, y limit we have to identify in the bounded region. Lower one, lower straight line or curve we have to look at it. In our diagram, it is as a constant straight line. So that is y equal to 0 will get. Then upper limit is another straight line, but not constant straight line. This you have to rearrange y equal to what? This one is x plus 2y equal to 2. Rearrange it as a 2y equal to 2 minus x. Next, y equal to 2 minus 2x whole divided by 2. Okay, like you have to change. That's what we are getting like this. See that where I kept the cursor. 2 minus x by 2. So in your screen, you can expand and see. So y equal to 0 to 2 minus x whole divided by 2 will get. That's a y limit. X limit is x equal to 0 to 2. So these two things put it in the integration. So that is 0 to 2, 0 to 2 minus x whole by 2 xy dy dx. So inner integration with respect to y. So that is function is xy. So x as a constant. First integration with respect to y. So y square by 2, apply the limit 0 to 2 minus x by 2. Okay, so upper limit for y by 2 minus x by 2, 2 minus x by 2 whole square. In that denominator 2, put it outside. That's why here they have mentioned as a x by 2. Lower limit y by 0, no value. So now this one expanded. Just expand 2 minus x whole divided by 2 whole square. Numerator as a minus b whole square expansion. Denominator 2 simply as a 4. Then x multiply inside. Then in the form of x and constant equation you get integrate with respect to x. Then apply the limit 0 to 2. Upper limit 2 first minus lower limit 0, no value. There those values simplify, you will get as a 1 by 6. Okay.
சார்,
Okay. Yes.
சார், நீங்க நேற்று நடத்தின முன்னாடி நேற்று பிபிடியும் அது எல்லாரும் அந்த அந்த சேர்த்து 3 பிபிடியும் சேர்த்து ஆஃபீஸர் குரூப் அனுப்புங்க சார், தேவை.
Okay. So end of the session we'll discuss. The recording is going on. Okay, please.
Okay, sir.
Okay. So the value of double integral e power minus x square, e power minus y square dx dy, both the limits 0 to infinity. What will be the value? So that is a simple problem only. So integral independent of x and y. First integration. I mean both the limits are same. 0 to infinity, 0 to infinity. Okay, 0 to infinity, 0 to infinity. So that is integral 0 to infinity e power minus x square dx. integral 0 to infinity e power minus y square dy. By substitution, we can make it. Okay, so that is substitute z new variable by x square. So in place of x square, substitute the variable z. So z equal to x square, that is dz equal to dx, sorry, 2x dx, and dz by 2 root z equal to dx. So substitution for dx is what? Dz divided by 2 root z. So these values substitute, you'll get 1 by 2 into e power minus z, z power minus 1 by 2 dz. So you will get, that is root pi by 2 by using gamma function. Okay, this gamma function already we have seen, that is limit, I didn't mention. So limit is 0 to infinity. Gamma function is what? Integral 0 to infinity e power minus x, x power n minus 1. What is that? X power n minus 1 into dx. For that, gamma n we can put, but here z power minus 1 by 2, we can make it as a one by 2. Yes, directly root pi will get for this case, gamma function. I mean, gamma 1 by 2 will get, gamma 1 by 2 is root pi. Okay, gamma 1 by 2 is the formula, gamma function. Gamma 1 by 2 is root pi. So outside the integration 1 by 2 as it is. Okay, the same integral value for y also. So these two values you have to multiply. That means root pi by 2 into root pi by 2. So that is root pi, we convert as a pi, denominator 2 into 2 as a pi by 4. Okay, got it. So this one is by gamma function. So to understand, refer the gamma function. It is in the form of z. There you will get in the form of x. And do remember, gamma 1 by 2 is equal to root pi. So using that, we'll get like this. It's also a simple problem. So the value of the quantity p, where p is equal to integral 0 to 1 x e power x dx, integrate by chain rule or Bernoulli's formula. So you will get integration u is equal to x, v equal to e power x. So x e power x minus 1 e power x. Okay, so u v1 minus u dash v2 plus u double dash v3 and so on. v1, v2, v3 are integration, and apply the limit 0 to 1. You will get e power 1 minus e power 1. Everything simplify, you will get 1. So it's a 1 mark question. So this is also, we had seen this 1 by x square. Usual one, take x square to the numerator and apply the integration. X square to the numerator and apply the integration. Using the formula, integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. See that the block letter, second line, using that formula, they are make it in that integration 0 to pi by 4 tan pi by 4 minus x dx as a tan pi by 2 minus x, integral 0 to pi by 4, that tan pi by 4 minus x as a tan pi by 2 minus x dx, tan pi by 2 minus theta, using that we'll get as a cot x, integral cot x as a large sin x, apply the limit 0 to pi by 4. Sin pi by 4 means 45 degree. So 45 degree value is 1 by root 2, sin 0, 0. This one is 2020 gate question. There are multiple routes to reach from the node 1 to 2 as shown in the network 1 to 2. The cost of travel on the edge between two nodes given in rupees. Nodes A, B, C, E, D, E, F, toll booths. The toll prices at all toll booths marked as marked A and E is 200 rupees 200 and rupees 100 for all other toll booths, which is cheapest route. Which is the cheapest route from node 1 to 2? The simple question, one more question. Which one is a suitable answer? You can think, for example, 1 to A to C, C to 2, one of the route. Otherwise, 1 to A to 2. Okay, direct path is there. That circle is denoted as a toll booths. So we have to calculate the amount. Simple problem only. So 1 to B, then B to 2. Okay. Another one, 1 to B, B to D, D to E, E to 2. Otherwise, 1 to F, F to B, B to 2. Otherwise, 1 to F, F to B, B to D, D to E, E to 2. Otherwise, 1 to F, F to E, E to 2. These are the possible routes. But here, 4 routes are given. Which one is the least cost? So if you take it up, 1A, C, 2. So 1 to A, so 200. Next C, A to C, 100. So 300. Next 400. So first one is 400. Second one, 1 to F, F to B, then B to 2. So that is 300. Sorry, 1 to F is 100. F to B 0. Next B to 2. So that is 300 totally will get. Second one 300. So first one is 400. So we omitted. Next 1 to B, B to 2. So that is 500 we are getting. So 1 to B 300, then 200. So total 500. So that's also eliminated. So higher than 300 we are getting, higher than second route. Next 1 to F, E to 2. 1 to F, E to 2. Sorry, F to E, E to 2. So that is 400 we are getting. So hence 300. So that is second route is the cheapest route. Second route is the cheapest route. Okay. Next, this is also 2020 get question paper question. Two straight lines are drawn perpendicular to each other in xy plane. If alpha and beta are the acute angles, the straight lines with respect to the straight lines make with the x-axis, and then alpha plus beta is what? Okay, the diagram is not given in the question paper. We have to choose. Acute means less than 90 degree. Okay, smaller angles. So two straight lines. So in this way, you have to think in the x-axis, y-axis. See the diagram for understanding. I have put x-axis, y-axis, two straight lines. Okay, intersecting, making. Perpendicular. They are perpendicular. Perpendicular means intersecting, making angle 90 degree. Perpendicular means 90 degree. So this straight line and this straight line intersecting, making angle 90 degree. That is called the perpendicular. If these are 90 degree and these straight lines intersecting axis, what axis? X-axis. Okay. When they intersecting, it will make an angle and it will create the triangle. It will create the triangle. Okay, so it's going on. The straight line further moving. This further you can extend the straight line. This one you can further extend straight lines. Okay, so here it makes angle 45 degree. This will makes 45 degree when they are uh, intersecting perpendicular. And one more thing, what is that? When you add up triangle all the degrees, you have to get 180. So So using that one angle, first angle, perpendicular angle, that is 90 degree. Other two angles we have to identify. So if it is a perpendicular and these two values, 45 degree, one of the case, okay, it can be other possibilities also, 60-30 also. Okay, 60-30 also. When you add up those two angles, surely 90 degree will get. Here it is asked alpha plus beta. Okay, one of the possibility 45-45, otherwise 60-30 also included. Okay, acute angles. So hence, when you add up alpha and beta, correct answer is 90. Okay, then only it will makes the triangle. Then only they can intersect the x-axis. Okay, this is one model. It's not exactly the same. Yeah? So any different two straight lines intersecting axis, these two straight lines passing through the origin also included. So DM question formula. So third one is the correct answer for the first question. Third one is the correct answer for all xp of x. Predicate calculus problem. Okay, so that has to be right hand side their axis dx. That's why it was wrong. Other things are correct. Next question, graph G is obtained by adding vertex S to the K3, 4 and making S adjacent to every vertex of 3, 4. The minimum number of colors required to edge color of the given graph. Okay, so K3, 4 graph that you are seeing it on the screen. The diagram will not be given, only the question. You have to draw and identify the graph. Okay, how many colors are required? Edge color. Edge. I mean, coloring is not there. Actually, we have to study. So different colors you have to give. Okay. So for example, first vertex, when you take it up, this vertex, how many edges incident with that? So that is degree 4. Okay. For that, 4 different colors you have to give. Okay. The adjacent vertices should not have same color. Okay. As per the coloring concept, edge coloring concept. We have two different coloring concept, vertex coloring and the edge coloring. Here, edge coloring. So in the edge color, adjacent edges are where they meet the vertex. They should not have same color. So we have to give 4 different colors for this first vertex. The same 4 colors you can take it up for the second vertex. Second vertex and the first part, but change the order. Okay, so color 1, 2, 3, 4. Here 2, 3, 4, 1. Next last vertex 3, 4, 1, 2. Like that you can give. So here it's based on the degree. So in the K3, 4, maximum degree of the vertex is 4. So hence for this case 4 is the answer. 4 is the answer to cover the K3, 4 for edge coloring. Okay, without contradict to the case. And they add up one more vertex. Okay, that one more vertex is what? S vertex. That S is adjacent to all those other 7 vertices. Okay, to take it up one vertex, new vertex S, from S to first partition all 3 vertices, second partition all the 4 vertices. So individual edge will connect. So that will be the maximum degree. So 7. So already 4 we have used. We need 3 more colors. So hence totally 7 colors are required for the edge coloring. That is the answer with respect to the coloring concept. These questions 2020 GATE questions. Okay, thank you.